Hi there. Today I'm going to talk to you about section 1.1 in our college algebra textbook. It's about linear equations and applications. So I just want to remind you that you're watching a video, so I'm not going to pause to let you write things down, so you can pause for as long as you need to write things down. So we're going to be talking about equations and solving equations. An equation is when you set two algebraic expressions equal to each other. And when you solve an equation, you want to do a few things. Every equation is different. So some general strategies are that you want to simplify and remove parentheses first and then combine like terms. And then you're going to add or subtract a number on both sides to try to isolate the variable. And then you're going to multiply or divide a number on both sides to try to isolate the variable. I kind of think of it as peeling an onion, trying to get everything to go away as you peel down to the variable. All right, so I'm going to show you how to do this one. So the first thing I would do is and everybody does things differently, but I would distribute the 5. So you get 5x minus 10 plus 4 equals 19. The next simplest thing to do would be to combine the 10 and the 4. So you're going to get 5x, it's a negative 10, so minus 10 plus 4 is minus 6. And then that's going to equal 19. And now we want to add 6 to both sides of the equation. Anything you do to one side of the equation, you have to do to the other side of the equation. And you get 5x now is by itself, and that's going to equal 25. And now you want to multiply or divide. To get the x by itself, I'm going to divide so that I can divide out the 5 on the left and get an x by itself. And now I get x equals 5. Okay, so that's the first example. And we'll move on to another one. Okay, the next example is just a tiny bit more complicated. You need to distribute every single one of these. And so we're going to get 3 times 4 plus x is 12 plus 3x. The next one is 2 times x plus 2, so I get 2x plus 4. And the next one is 2 times 2x minus 1, 4x minus 2. Okay, so next what I like to do is combine like terms on the same sides before I start moving things around. So I have a 12 and a 4 that are similar, and I also have a 3x and a 2x. So I'm going to do the x's first, and I get 5x when I add those two together, and then 12 plus 4 is 16, and then I have 4x minus 2 on the other side. All right, so when you get really good at this, you can just do everything at once, but I'm going to do things one at a time. So I'm going to take the x's over to the left side. So I'm going to say minus 4x on both sides, and that's going to make the x's go away on the right side. And I'm going to get, that will cancel out, and I get, or subtract out is a better way to think of it, and we get x plus 16 equals, and this is a negative 2 because it's minus 2, so negative 2. Next I want the x by itself, and I'm going to get it by itself by subtracting 16 from both sides. So the 16 subtract out, and I get x equals negative 2 minus 16 is negative 18. Okay, so next I'm going to have you all try this, this next check it out one. So give that a shot, and I'll have that in the Edpuzzle. Okay, for the sake of time, I'm not going to work all of these out step by step for you, but I will show you the solutions to most of these. So I wanted to show you over here on the left, I've worked it out. I wanted to point out that x does not have to be on the left side. It can be on the right side. 6 equals x, x equals 6, it means the same thing. So whatever's easier for you to do in terms of solving, I like to avoid negatives on my x's because it keeps me from making mistakes, and I think that's true for most people. The other thing I wanted to point out is check your work. This is really, really important. Check your work. So plug your 6 in, see if it actually makes the equation true, and in this case, yes, it made the equation true. All right, we'll be moving on now. Okay, the next method is to solve equations with fractions in them, and that's just when the x is on the top. for this example. So you want to clear the denominators by multiplying both sides by the least common denominator. So the least common denominator of 5 and 2 is going to be 2 times 5. So that means we need to multiply everything on both sides by 2 and 5. So now we're not going to multiply by 5 over 5 and 2 over 2 because now we have an equation and we can multiply both sides. So now we're trying to get rid of the denominator altogether. This is a little different than what we were doing last time. So I'm going to multiply this whole side here and this whole side by the same thing. So I'm going to multiply it by 5 over 1. And I'm also going to multiply it by 2. So by 2 and 5. In other words, we're multiplying by 10. But when we multiply by 5 and 2, it's going to cancel out. So I'm going to distribute this so you can see exactly what I'm doing. So I've got 2 times 5 times x minus 1 over 5. And I've got 2 times 5 times x over 2. So it's not 2.5, that's 2 times 5. And that equals 4 times 2 times 5, which is 40. Okay, so on the first expression, I've got the 5's dividing out. And on the second expression, I've got the 2's dividing out. And as you get better at this, you can skip some of these steps, but I wouldn't do that at first. So you've got 2 times x minus 1 plus 5 times x equals 40. So now I'm going to distribute that. 2x minus 2 plus 5x equals 40. And then we've got the 2x's, the 2x and the 5x we can combine together. So I'm going to do that next. And I get 7x minus 2 equals 40. Now I'm going to add 2 to both sides. And the 2 is going to subtract out. And I get 7x equals 42. Now I'm going to divide both sides by 7. And I've just run out of room a little bit, so I'll scoot things down. And the 7's are going to divide out, and I'm left with x equals 6 again, strangely. I get x equals 6. So again, I would check this, and you're going to do that by putting 6 in for x. You're going to say 6 minus 1 over 5 plus 6 over 2 equals 4. Is that true? Well, you get 5 over 5 is 1, plus 6 over 2 is 3, equals 4. And yes, that is true. So we've checked it, and it works. So next, I would like you to work out the Check It Out 2 here, and put your answer in the Edpuzzle quiz. Okay, so here we are with the answer, and you should get x equals 5. Hopefully you checked your answer before you put it in and hit send or whatever. All right, so let's move on to the next thing. All right, so next we're going to look at solving equations that have decimals. So hopefully you remember your decimals and your base 10 numbers. But what you want to do to solve these is multiply both sides by the smallest power of 10 that will eliminate the decimals. So in this case, what we see is we have something, if we multiply this first one times 10, it would make it be 4. But if we multiply the 0.05 times 10, I would still have a decimal. So I need to go up to 100. So that means I need to multiply both sides of this equation by 100. So I'm going to scooch this over a little bit so I have a little bit more room to work, and we'll get started with that. So 100 is what we're going to have to use. It's the smallest power of 10 that's going to eliminate every single decimal. So you basically need to look at the smallest number and go from there. All right, so I'm going to multiply this side by 100 and this side by 100. And remember, when you multiply times 100, you're moving the decimal point over 2 places to the right. However many zeros there are in the base 10 number, that's how many decimal places you're going to move. All right, so I'm going to go ahead and multiply, and we can multiply it times this before distributing it, but we don't multiply it times these two because we're going to distribute this number across. If that confuses you, distribute it first and then multiply it times 100. But I find that a little bit tedious. So I'm going to multiply this, and I'm going to get, so I'm going to move it 2 places. So I'm going to come over here to work. 0.4, I move that 2 places over, 1, 2, and I'm going to get 40 with the decimal point here. So this is 40 times x minus 2, and that's going to be minus, now the 100 is going to be multiplied times the 0.05, so now we have 0.05 times 100 means that we're going to take that decimal point over 2 places, and we're going to end up with a decimal point here at the end. All right, so that gives us a 5. So this is 5x, and we're going to get the similar thing as the 0.4 with the 0.7. The 0.7, we're going to move over 2 places to the right. So 1, 2, we have to put a 0 in there and put a point. All right, so my equal sign's a little messy, so let me fix that for you. We get 70 here. So now it's much easier to work with without the decimals, and since we've multiplied both sides by the same thing, it hasn't changed our answer. So now we're going to get 40x minus 80 when we distribute the 40 minus 5x equals 70. Don't skip steps here, that's where people always make mistakes. So I'm going to combine the 40 and the minus 5, and I get 35x minus 80 equals 70. I'm going to use a different color here because I think it might help. I'm going to say plus 80 on both sides, and the 80s are going to subtract out on the left. 35x equals 150. So now I'm going to divide both sides by 35, and the 35's divide out, and we're going to get x equals, the easiest way to do this really is to put it in your calculator, but what they're generally looking for in these kind of problems is an exact answer, and when you get a decimal you have to round it. So the best way to do the answer for this is just to reduce this, and if you look at what's going on here, you see that both top and bottom are divisible by 5, so you're going to want to come back up here and divide top and bottom of the 150 over 35. Well, here, let me do this down below. I think it's more clear. 150 over 35. We're going to divide top and bottom by 5. So we're dividing by 5 over 5. So divide top by 5 and bottom by 5. And however you want to think about that for reduction, but then that's going to be 30 over 7. So your final answer is 30 over 7. Okay, and now it's your turn to try one. So give this one a shot. Think about what power of 10 you need to multiply everything by and first, and then distribute that through and solve for x. Okay, so you needed to multiply both sides by 100, and you should have gotten x equals negative 48 over 117, and you can go through my work to see how I did it. I prefer you don't do decimals like I said in the last problem. All right, so I'm going to move forward here to solving for one variable in terms of the other. So if you're given an equation with all variables and you need to solve for a variable in it, you do it just as if there were numbers there. You just can't really combine most of them. So in this case, if you're going to solve for b, a great thing to do is to do something like circle it or underline it in a color or highlight it or use some sort of color. And then you want to have it all by itself and get rid of everything else. So I'm going to say minus a, minus a, minus c, minus c, okay, on both sides. And so I'm left with b equals t minus a minus c. That's a terrible c. I'm going to redo that. So that is all it is, and that's solving for one variable in terms of the other. To give you another example, d equals rt. This is just a simple physics equation. and distance, rate, and time. So we want to solve for r. So again, I'm just going to circle the r. You can also underline it or something so you know it needs to be by itself. So what I'm going to do to get it by itself, we want it on top. Don't get hung up on having it on the left. That's not what's important. We want it on top and by itself. So what I'm going to do here is divide both sides by t. And so that way the t gets divided out here, and we are left with r equals d over t. Okay, or d over t equals r, but you can just switch the sides. It doesn't matter what's on the left and what's on the right. Okay, all right, so the next one, we're going to solve for r again. So this is a little more complicated equation, so we want that r right there. And I'm going to have to get it by itself. It's on the left already, and it's on top, so we don't have to worry about that. So what I want to do is I want to subtract this 3s from both sides first, and I'm going to get pi r equals, and the 3s cancels out or subtracts out, equals L minus 3s. So it's always important that you do the addition and subtraction first, and then you do what's multiplied to the r. Because now what we're going to do is we're going to divide everything by pi, and you end up with r equals L minus 3s over pi. Okay? All right, so there's a couple of examples of solving for a variable in terms of other variables. Now I'm going to start talking about some word problems. So this question says if F denotes a temperature in Fahrenheit and C is the same temperature measured in Celsius, then they're related by that formula right there, which you've probably seen at some point. And they want us to rewrite the expression to solve for C in terms of F, because that's sometimes what we want to do. So we might as well have it rearranged. So this time we're going to solve for C. We want it by itself. All right, so the first thing we want to do, we don't care if it's on the left, or we can just switch it right away if that makes you feel better. A lot of people get hung up on that and do some weird things with making C be on the bottom and stuff. So just switch the two sides, and then we can go from there. So now C, the thing we want, is on the left. And that's what we were looking for. So now you want to look for what you want to do next. So remember, you want to add and subtract first. And so we're going to subtract out this 32 right here. So I'm going to say minus 32. So I get 9/5 C equals F minus 32. All right, now in order to get rid of a fraction like this, we want to multiply by the reciprocal. So if I multiply by 5/9 on both sides, and I want to do it to the whole thing like that, then I'm going to have the 5 divide out and the 9 divide out. And I end up with our formula that we're looking for, C equals, and I'm going to put the 5/9 in the front, because that's usually how we see things, 5/9 F minus 32. So that's how you would convert if you knew Fahrenheit and wanted to find Celsius. Okay, bring any questions to class that you might have. So write these things down and bring them to class. All right, the next one is the surface area of a sphere with respect to its radius. And what if we knew the surface area of the sphere, but we did not know the radius and we were trying to find it? And especially if we're doing it over and over again, it's good to have it rearranged. So we're looking for this r right here. Now we want to deal with the exponent. I'm going to erase that so you can see the whole thing. We want to deal with the exponent last because it's only on the r. So what we want to do first is we want to, and again, don't care if it's on the left or right, but I think what I'm going to do is I'm going to rearrange it so that it's just switched. 4 pi r squared equals s, so that way we can not worry about the fact that it wasn't on the left. Now it is on the left, and we're looking for r. So here's the thing we're looking for. So I'm going to divide both sides by 4 pi, because it's not added to anything, so we don't have to worry about that. So 4 pi on both sides. So the 4 pi divides out, and we're left with r squared equals s over 4 pi. Now, how do we get rid of a square? Well, what's the inverse or the opposite of a square? And that is a square root. So if we square root a square, then it basically goes away. So we're going to say, all right, well, we're going to square root this. And there's a 2 here, but we don't really need to write it because we don't usually write it if it's a 2. And then that means I have to square root the other side as well. I have to do the same thing to both sides. All right, so now what we get is square root of r squared is just r equals the square root of s over 4 pi. All right. The last thing I want to talk about is doing word problems. This is a technique that I like to share with people because it is really helpful for many science classes and all word problems. So first you need to read the problem through at least one time. Then take it apart. List every known variable and then assign each variable a value or a question mark. Determine the equation that's going to be used and write it down. Or sometimes you have to create the equation, and we'll get to that later. And then you want to choose a method to solve for the question mark. So you're going to rearrange the equation and then plug the equation and then plug in the numbers like we just did in the previous ones, which I believe is easier. Or you can plug in the numbers and then rearrange the equation. All right, so I'm going to give you an example here. We're going to take this apart. Find the height of a rectangular box with a length of 8 inches, a width which is double the length, and a volume of 144 cubic inches. The volume of a rectangular box is given by this formula right here, where L is length, W is width, and H is height. So we now know what the formula is, and I'm going to write it over here. V equals L, W, H. So we're dealing with 4 different variables here, okay? So what are we trying to find? We're trying to find the height, but I'm not going to really worry about that right now. So what I want to do is I just want to kind of skim back through the problem and look for, what am I looking for? I'm looking for 4 different things, and that's given to me pretty straightforwardly by the equation. So that's why I wrote it down first. Now I'm going to go over here and I'm going to say length equals, width equals, height equals, V equals, okay? And then I'm going to go looking for stuff. So I'm going to use red. Find the height of a rectangular box with a length of 8, and it says find the height, okay? Find the height. So find the height, that means that is our big question mark. That's what we're looking for, okay? In other words, we're probably going to have to rearrange this equation for H. All right. It has a length of 8 inches. Great. So now we know the length. It's 8 inches. I'm going to use units just in case they throw feet at us in one of them. You never know what they're going to do, so just give yourself all the information you need. A width is double the length. Well, okay, great. So it didn't give us a number, but it's 2L. It's twice the length. It's double the length. However you want to think of it, it's 2L. And the volume is given as 144 cubic inches. All right, well, they didn't throw any new units at us. It's 144. And of course, it's cubic inches because it's got 3 dimensions, length, width, and height. So it's going to be cubic. All right, everything's pretty straightforward. So we're going to rearrange this formula for H, which means I'm going to divide. Well, first I'll rewrite it. So we've got L, W, H equals V. And now I'm going to solve for H. So I'm going to divide everything by LW to get H by itself. And now I have H equals V, the volume, over the length times the width. Okay? So I'm going to have to scoot this down just a little bit, make a little more space. And so now we've got, we are trying to find H. We know the volume, we know the length, and we know the width in terms of the length. So we're going to plug in volume is 144, the length is 8, and the width is double the length. Well, the length is 8, so that means 2 times 8, so that means the width is 16. Okay, so now we've got 8 times 16. So now all you need to do is just put all of this in your calculator. So we've got 144 divided by 8 and 16, and we get 1.125. So the height is 1.125 inches. Okay, I've got a couple more problems here. I'm sorry this is a long video. This is a long section, which is why I'm doing a video instead of doing it in class. Okay, so simple interest is an equation that you're going to use a lot for lots of reasons, and it's something you should be very familiar with so that you understand what's happening to your own money. So I equals PRT is the basic equation. It gets more complicated than that, which we'll use logarithms for, but this is a very basic form of it. And so I is interest that you've made or paid, depending on if it's a loan or a savings account. P is the principal, which is the money you start with. R is the annual interest rate, and you have to write it as a decimal or it doesn't work. So if it's 6%, it's 0.06. T is time in years. So if it's a quarter of a year, if it's 3 months, you have to write 0.25. So it's got to be in years. Okay? So what we're going to do here is just like I did before, we're going to write all of our variables. Always do this. Don't skip it. This is the method I'm showing you, and it really does work. And it's applicable in chemistry and physics and all sorts of other science classes. Find the simple interest earned if, that's supposed to be if $4,000 were invested at a rate. So $4,000 is one of our things that we're looking for. So what is that? That is the principal. That's what you invested. So the principal needs to be here, $4,000. Okay, so 4,000. If that were invested at a rate of 2%, so here's another thing that we are looking for, rate of 2% annually for 6 years. Okay, and we're find the simple interest. I'm going to circle that because that's what we're looking for. Okay, so all of these little things that you do really can help. So we're looking for the interest. The rate is 2%, so I'm going to put 0.02, and the time is 6 years. It's supposed to be in years, so we're just going to leave it as 6. All right, so now I'm going to write the formula. I didn't rewrite it before because it was just right up above for us. So I equals PRT, but it's a good habit to get into just writing the formula right away. Okay, the next problem is a 4% loan was taken out at a simple interest for 7 years. The total amount paid back was $83.20. That means we're going to be doing something a little bit different this time. So I wrote down IPRT, but we're going to change this up just a little bit. So it doesn't always work every time to just perfectly fit into the equation. Sometimes you have to do something special. So we've got the 4% loan here. I'm going to do it in red. And we've got 7 years. So we know those two things are pretty straightforward. So the loan rate is 0.04 and the time is 7. But what we know is these two put together, I and I plus PRT, and I'm sorry, I plus P. So the interest plus the principal is the amount you pay back at the end. So that's going to be the $83.20. When you pay money back at the end of a loan, you're paying back what you borrowed plus the interest, so principal plus interest. So I want you to think about this for just a second. We need to get rid of one of these two things, and we know that I and PRT are equal to each other. So what we're saying is that I plus P equals 83.20. That's what this is saying right here. The interest and the principal together are 83.20. Well, we know the interest is PRT, so we can just replace this right here with this right here, the PRT. Okay, so pause and think about that if you need to. So I've got PRT plus P equals 83.20. Okay, so we only know at this point the R and the T. So think about how we're going to do that next. So one way to do this is to factor it and leave the numbers out. The other way is to put the numbers in and move from there. I'm going to do that because I think it's going to be more straightforward for most people to see the numbers. So we get P, which is still unknown, times 0.04 times 7 plus another P that we still don't know equals 8320. So this gives us 0.28p, that's 0.04 times 7 is 0.28p, plus another p equals 8320. Well, it suddenly got just a little bit less complicated because remember that when there's nothing in front of a variable, there is a 1. Okay, so we're going to take the 0.28 plus the 1, and we're going to get 1.28p equals 8320. And now we're just going to simply do what we've been doing, divide by 1.28 on both sides, and we get p equals 8320 divided by 1.28, which is 6,500, and it's dollars. Okay, so the principal was originally $6,500. So now if you wanted to figure out the interest, you could, but that's not what the question is asking for. All right, that is the end of this very long lesson. So hopefully you followed all of that and you took lots of notes and you've got some questions for me. You can always go back and look at things again and again as much as you want. All right, thank you. Bye.